Hello viewers, this video series is for the readers of Unified Modeling Language User Guide by Grady Booch. We are in chapter 1, the first video, why we model. Before going into the discussions, we have to define a model first. Then we will see the various reasons for modeling and its importance, etc. The UML is a graphical language for visualizing, specifying, constructing and documenting the artifacts of a software intensive system, where a model is a simplification of reality. In other words, a model provides us the blueprint of a system. If we need to go a little detail about this, the UML gives us a standard way to write a system's blueprint. It covers conceptual things, it covers concrete things. Conceptual things like business processes and system functions. Similarly, concrete things like classes written in programming languages, database schemas, reusable software components, etc. Well, we will see the importance of modeling. See, modeling is important because it communicates. Model communicates our system in a better way. There are various reasons for modeling or choosing models. However, we can put it into 3 points. A model is a simplification of reality. It is for best understanding the system before developing. It is used to design complex systems in a understandable way, and if we go more about that, models are for to capture and precisely state the requirements and domain knowledge so that all the stakeholders may understand and agree on them. Is models to think about the design of a system. Model is some way to capture design decisions in a easy way, taking requirements into the consideration, and it is to generate usable work products, and it is to organize information about large systems. It may use to find information, may use to filter the information, retrieve, examine, or you can modify somewhere, edit the information about large systems. Similarly, it is to explore multiple solutions economically, and it is to master complex systems, so design complex systems in an easy way. That is actually importance of modeling. Well, we will see the principles of modeling. Generally, whenever we take up some concept, we will definitely follow some principles related to them or related to that particular concept. Similarly, here for modeling also we are having some basic principles. First one, the choice of what models to create. See, we will choose our models in an efficient way. The right models will highlight the most important development problems. and wrong models may mislead us, and they cause us to focus on irrelevant issues. Second principle, see, every model may be expressed at different levels of precision. Sometimes a quick and simple executable models of the user interface is exactly what we need. At other times, we have to get down to complex details such as cross-system interfaces or networking issues, etc. In any case, the best kinds of models are those that let you choose your degree of details. I mean, that is all depends on the way you view that model. An analyst or an end user will want to focus on issues of what, and a developer will want to focus on issues of how. See, analyst's way or his view is different, and the developer's view is different, or end user's view is different. Accordingly, our model must have some kind of design for the end users, some kind of design for developers, like that. For example, suppose if you want to explain how your system, software intensive system, will work, a simple use case view is more than enough. If you want to explain the technical details about that, or the programming details about that, at that point you need some kind of class diagrams, component diagrams, some kind of interaction diagrams which explains how objects interact together. So definitely model must be expressed at different levels of precision. The third principle, we can see the best models are connected to reality. In software, the gap between the analysis models and the system's design model must be very less. We have to do analysis which reaches to the reality. Failing to bridge that gap may cause the system to diverge over time. In object-oriented systems, it is possible to connect all the nearly independent views of a system into one whole. Well, we will see the fourth principle of modeling is no single model is sufficient. See, in this case of a building, you can study electrical plans in isolation, but you can also see their mapping to the floor plan, and perhaps even their interaction with the routing of pipes in the plumbing plan. See, we need a separate plans for that. So single model is not sufficient enough to design entire system. This is true even for object-oriented systems. To understand the architecture of such a system, we need several complementary and interlocking views. In use case view, we may expose the requirements of the system. In design view, we may capture the vocabulary of the problem space, and similarly in the solution space also. In the process view, we model the distribution of systems, processes and threads. Similarly, in implementation view, we will address the physical realization of the system. And in deployment view, you all know, focusing on system engineering issues or where to software live, how software work furtherly, that is all different. See, in different views we need different kind of presentation. To realize such a presentation we need different models for different views. That is why we can say strongly that no single model is sufficient enough. Well, we will go with a discussion about object-oriented modeling. We all know in software development process usually people will follow two approaches: algorithmic approach and object-oriented approach. What will we do in algorithmic perspection? What will we do in object-oriented perspection? That is important for us. Well, before going through the object-oriented approach, we will see what is algorithmic approach, so that we can understand object-oriented approach in a better way. Well, what is an algorithmic approach? The traditional view of software development is algorithmic approach. We will take a problem statement, we will make it into, entire problem space into smaller ones, and we used to solve all small problems in a order. We decompose the larger algorithm into smaller ones. We will implement all them in different functions, and all functions are called whenever that particular small solution plays a role in the system's execution. Well, we know that in a we are well aware of algorithmic perspection, but what would be the object-oriented perspection? This is what actually matters. In the contemporary view of software development takes an object-oriented perspective. In object-oriented modeling, the main building block of all software systems is the object or class. Simply, we'll put an object as a thing generally drawn from the elements of the problem space or a solution space. If we need to define a class, we can define like a class is a description of a set of common objects. Every object will have its own state, it will have its own identity, it will have its own behavior. Well, this object-oriented perspection is a modern approach actually, where the communication between objects can be established through messages, and it is literally easy to maintain, and it is easy for further enhancement. For example, let us consider a simple three-tier architecture for a billing system. Billing system involves a user interface, a middleware, a database. What user interface will do for us? User interface, in the user interface we will find concrete objects such as buttons, menus, dialog boxes, radio buttons, etc. In the database we will find concrete objects such as tables, entities, attributes. Okay, in the middleware we find objects such as the transactions and business rules. The object-oriented approach to software development is a part of the mainstream development simply because it has proven to be of some value in building systems in all sorts of problem domains and cover all degrees of size and complexity. Well, we understand or we discussed about what is an object oriented perspective or approach in modeling. Well, this is all about chapter 1 of why we model, and the next chapter will be discussed in the next video. Thank you, yours Uday Kumar.